So let's jump forward though and talk about now that I've got some documents and embeddings and I could do something with them. Let's also talk about models, right? You can start to see how these things are put together. We got a model service and the model file service, which is two kind of abstraction layers Kamiwaza provides for dealing with those. And you can see we've got a model. We're using Open Hermes 2.5 Mistral 7B as the model for our demo. I picked that because although I've got some pretty beefy hardware to run on, because this runs on a Mac, any M chip Mac, we wanted something that's reasonably small, right? So the GGUF file here only requires about 4 to 5 gigabytes, I think, of memory to really run on a Mac and should run reasonably fast. Probably an M1 MacBook Air can probably do this. So I'm specifying my target model and I'm running a search. So I run search models on that target model. I say hub search star, I've got our model list, and then I get the list of files for that model. I happen to know I'm only going to get one because this is essentially an exact query. If I were to come up here and look at the models and I were to search for Open Hermes GGUF, and I get the same list, hopefully everybody's are like the blokes. Yeah, you see this, there's different weights here. And so we don't really want to download all the weights. And so what we're going to do is we're going to specify the particular weights file. We're going to grab the Q4KM. If it's Linux, we're just going to grab all the files because the AWQ version only has a single model.safe tensors. I think it's always 4-bit. So we say what files we're going to download. I probably should have started the download first, but we're going to go ahead and say create the model service. We already have the model service. We're going to tell the model service download those files. So you see that. And actually, in the other window, which we haven't been paying a ton of attention to, you can see there's a bunch of download stuff that's kicking off, right? And it's doing checksums and things. In the background, all these things are working, and we're going to actually see these files disappear from here until they're done. And that's probably about to happen. Done. Finishes checksumming all the files or downloading them. For you, would be downloads. I happen to have them locally already, so it's a little bit faster. And now we're going to create a deployment with them. So we have those model nodes. And incidentally, if I go back here and look at this models page now, you can see I've downloaded this file, right? And there's no deployments yet, but it did create a default model config for us. So if I want to change things like a context window, I can do that in the config. But I'm going to go ahead and tell the model service to get the first config. This is going to be the default. We saw it only had one. So I say model service, get model configs for the model, pick the first one, grab its ID. And then so I specify that along with the model ID, and I say Kamiwaza serving service, deploy it. And it says, hey, Docker container started with ID. Now we've got the deployment up, and I'm going to go and look at the deployments. And this should actually just list the deployment. You can see I've got a deployment ID, but Kamiwaza knows the host name and the path and the status of the deployment, right? And I can probably load this and actually see its OpenAI docs. So this is an OpenAI compatible API that Kamiwaza has turned up. And again, if I come back here, I can see I've got this deployment. Same thing here, I can click that and I get the same API as I got from the code. So it's deployed, and now I'm going to list it. If you think about this programmatically, other applications can consume the Kamiwaza library to know what models are deployed on what endpoints with what ports. And across a cluster in enterprise mode, that includes across the cluster, which means you can programmatically understand what's available. Do you need a deploy model? Can you use an existing endpoint? Things of that nature. Let's go on to Inference. We'll actually see us consuming this. So here we're building an application that from the command line does a bunch of inference. We're going to install the OpenAI library. And if I was running this on OS X, I would leave this prompts to run because with Llama CPP, there's only a certain number of slots that you can hit. VLLM loves actually to consume many requests. And so because we're on Linux for this demo, we'll comment that. We'll say prompts to run -1, meaning run all of them, which as you see here is actually a lot. And again, I'm suppressing noisy debug, but I've got about 100 and some odd prompts, 108 that we're going to use. They're all related to just telling it to create code. But what I'm doing here is I'm listing those Kamiwaza deployments, serving service list deployments. And I'm going to use that though. I say, give me the first deployment. In this case, cheating because I know there's only one because we're doing this demo. And I'll print it, which again, same one I saw before, but you can say I know what model it is. And then I'm going to specify the things I got from the Kamiwaza API into the OpenAI library. So when we make calls, instead of using OpenAI, it's going to use our model instead. And you can see I specify key as just local. I'm going to define a pair of functions here. One is to go fetch response, which means go hit the chat completion API and get it, right? It's got a system prompt and a timeout. And otherwise, it's just a totally vanilla OpenAI API call. And then I've got this main prompt. What it's doing is it's getting all of our 108 prompts, and it's creating a bunch of execution threads to spawn them all and do this en masse. We're going to come down and run it. So we say main, we say if we define a limit to the prompts, then run that number, otherwise run them all. And so we see inference starting to happen now. Now, this is running off my Linux system here. This is running on an RTX 4090, so it's about computationally equivalent, rough and tough, to an A100 card, which I guess you may or may not be more familiar with one or the other. But it's basically using that engine that Kamiwaza deployed to generate responses for all 108 code prompts now. And I've seen this take anywhere, depending on how verbose. Models are not deterministic. And I've seen it take anywhere from about 60 seconds to 90 seconds or so to generate this. Anywhere from maybe 850 to about 1200 tokens per second for this particular set of prompts. A lot of these are really open-ended too. Write me a Python-based football game in JavaScript or whatever is something that can go a lot of different ways inside of a model. So in this run, we got 85,000 tokens from all those prompts. That's an average of 789 tokens per prompt, including the input prompts. 1,156 total tokens per second. So pretty quick. That's 108 generations, and you can scroll up and see it's an unreal amount of output we just got out of it. Ooh, no problem. Fun stuff. Now, what's really interesting about this, and what's cool, and I'll just touch on this one more time, that's the last of our notebooks. It's early days for us, but we'd love to see you on our Discord server and give us some feedback and tell us how you'd like to use it, because there's a lot of work to go.